This is the second video for the 7-1D lesson. So you hopefully have worked through now the next two scenarios. So you've completed one that was about Kyle, and it looked like this. Had a kind of a cool map with a fork in it. It had this graph, and we say that it wasn't a function. That specifically, when you put two quarters in, you couldn't determine how many bouncy balls you get back. We did not talk about the fact that it was not linear or wasn't proportional. Again, that is not included in any of these justifications, although maybe that's the case for some of these graphs, like number one. Um, this one involving Allison was kind of a cool graph, and it had a kind of a crazy map that kind of keeps going. And this is kind of a barrel of fun, so to speak, for a vending machine. You put one quarter in. You can only put one quarter in, and you kind of randomly get some number of balls. You're not going to know what it is. And this machine isn't working in the traditional sense of a vending machine or a gumball machine or, in this case, what bouncy ball machine. And mathematically, this also is not a function. Although, if we look at it, is it a line? It is a line. So this is what I was saying in the first video, is that we are not saying necessarily that things are linear, although we will maybe talk about that in this module, but that's not what makes this not a function. In fact, if you look at this one and you look at this one, you start to see the issue. And the issue is that the input of two has two different outputs. There's a fork. And same thing happens here. An input of one has, well, I suppose, infinitely many outputs. And so when we get to then the definition, and you read through a paragraph similar to this on the Desmos slide, but it really comes down to this statement. A function is a relation in which each input is paired with exactly one output. It's that simple. That's our tagline, just like with Mod 2, when we talked about proportional relationships. The easiest one for graphs was it's linear and passes the origin. And we're going to stick with this. We really shouldn't even bother to alter this, because in changing this somehow, this statement, or rearranging it, we might somehow make the statement actually different, maybe not have the same truth value. It might actually be false. So the test of whether something is a function, notice it doesn't say it needs to be linear. It could be disorganized. It could be a scatter plot. Could be nonlinear. Could be discrete or continuous. Could be proportional or non-proportional. None of that matters. It's all about each input is paired with exactly one output. And this input is paired with infinitely many outputs. And one of these inputs, specifically two, is paired with two different outputs. So that is the deciding factor. If we just deleted one of these or both of these, this would be a function, even though maybe it's weird. It would be considered a function. But because of these 2 points, both being there, it is not a mathematical function. So it's as simple as that. Whenever we're asked to justify, I would stick with this statement and avoid using the words line or predictability or other things. We're just looking for whether an input is paired with exactly one output.